I'm going to give two different methods for this question. So I decided to go straight in and just use numbers. We're told that the area of the small square is a quarter of the area of the large square. So I went ahead and said that this one is going to be 4. It's a 2 by 2 square, because that's easy to find a quarter of. A quarter of 4 is 1. So the lengths of the smaller square are going to be 1. And that makes things really nice. Because we know the rectangles are congruent, then I know that this length plus this length, maybe I call it x, 2x plus 1 must equal 2, and therefore x is going to be 0.5. You might not even need to write an equation down, to be fair. You can maybe just see that they've got to be 0.5 to make it add up to 2. And that means if this is 0.5 as well, because remember they're congruent, then this length here, the longer length of the rectangle, is going to be 1.5. So let me just draw my rectangle out. I've got a length of 0.5 here, 1.5 here. So the ratio of the length of a short side to a long side is 0.5 to 1.5, which becomes 1 to 3. Really nice approach. Here's a slightly more algebraic approach. So I'm going to start off with the rectangle now and say the short side is x and the long side is y, which means this length is going to be x plus y. Okay, and then because this is also x, then I can now work out the square's dimensions in terms of x and y, because it's going to be x plus y minus x minus x. It's actually going to be y minus x. You can see that this will still add up to x plus y overall. And then I'm going to bring in the fact that the area of the large square is 4 times the area of the small square. So that means the area scale factor is 4. And we can now square root that to get the length scale factor, which is going to be 2. Of course, you require knowledge of that topic, but it's going to work really nicely because now I can say, okay, so my length for my big length is x plus y, and that must be twice my small length, y minus x. This becomes 2y minus 2x, which means 3x is equal to y. And that is another way of saying that y is 3 times as big as x, and therefore it's going to be in the ratio 3 to 1. We could also, sorry, was it? I can't remember if it was small to big. It was, wasn't it? So if I was going to write down x to y, I can now write it down actually as x to 3x, which then simplifies to 1 to 3. So both good approaches. I've got to say, I think this one with numbers is a little bit simpler, and it is okay because under enlargement, the scale factors are going to stay the same, the ratios are going to stay the same, but you might prefer this method, I don't know.